we heard there that Murugan highlights the complexity of scaling digitalization while maintaining local needs. And this was taken from the Automotive Manufacturing North America conference back in October. And leaders in automotive manufacturing really pushed for a kind of data-driven, people-first way to handle digital transformation. This is what we were seeing across the entire thing. They talked about weaving in technologies like AI and digital twins and automation to tweak existing processes without major disruptions, all the while tackling the skills gap and through upskilling and sharing knowledge. One key highlight, was grabbing that kind of hard to articulate know-how from older workers heading into retirement and passing it on to the younger crowd, with experts suggesting upskilling programs, design thinking, catalyst teams, and approaches to capture retiring experts' knowledge into models and LLMs to close those gaps, which is actually quite an interesting take, because again, it's people-centric in the fact that you're recognizing that it's the workers who are edifying the LLMs as opposed to the other way around. The whole event drove home that the digital transformation in manufacturing relies heavily on being able to effectively upskill the workforce and capture this tacit knowledge. And they noted how to beat pushback with things like training, clear incentives, leadership alignment, and practical demonstrations of benefit, the what's in it for you approach. And we saw panels from companies like Stellantis, GM, and Bosch emphasizing mixing digital tools with lean practices, pointing out that digital tools increase the speed of learning and reduce variation, but the human problem-solving layer remains essential. And I think that is really the key message here. If you're considering digitalization or automation without centralizing the human element, then you're going to be missing a trick. We saw that Toyota Motor Manufacturing UK is also addressing a skill shortage in the automotive industry, driven by an aging workforce at its Burnaston plant, where over 300 technicians are nearing retirement. Again, that's no small number. And to build a long-term talent pipeline, Toyota has implemented a hybrid apprenticeship program in partnership with Rockwell Automation and the local college. And the program includes 2 years of classroom training on technical skills using real hardware like control systems and simulation software, plus behavioral competencies. So the academy recently upgraded to current Rockwell equipment to better prepare for modern systems. And then I spoke to industry consultant Stephen Hyrene from Rockwell, and he noted that this training helps bridge legacy manufacturing with new technologies like electrification, autonomous vehicles, emphasizing hands-on real-world applications, again, putting the people at the center of these technologies. And I quote, he said, training must reflect real-world applications. It doesn't help learners if equipment is decades out of date. The upgrade ensured that the tactile experience resembled what they will encounter in working factories. And this project matters for a people-centric approach in vehicle production because it prioritizes workforce development amid automation and digitalization.
Yeah, and that again, you know, this kind of this core of people-centric running through everything and cross collaboration. And interestingly, I mean, I was talking to someone saying about they've got great engineers, but they're all due to retire.
Right,
as filling that skills. Exactly what you were saying there. There's a big challenge with that, and automation does provide some kind of solution with that. And that brings me nicely on to our next guest.
There we go.
Someone who knows a lot about automation. This is our kind of slightly deviating. We're going on to talk a bit about EVs, and we wanted just to get some insights around kind of where things were at the moment. So if I could just bring in Riddhi Padaria. Riddhi?
Yes, thank you for having me.
Hi, Riddhi. Nice. Thank you for joining us. Just to give some context, you are an industrial automation expert. I know one thing that will really pique the interest of our audience is that you work for Tesla on their automation systems. So
Mhm.
we might touch a little bit on that. You've diversified doing automation for other industries. I know you and I were speaking a couple of weeks ago about this, and you've also been working on standards for automation, sort of industry standards, which was really interesting. We just want to tap a little bit into your EV know-how and knowledge. And I know you're not working for Tesla now, but I just wanted to get a sense of what you see going on in the industry. So just having a look at things like, again, it's not been in the news a lot at the moment, but obviously it's still ongoing. So things like bottlenecks in scaling battery pack production. I think BMW just put out, I think they've just set up a factory. I think we were just talking about this, about how you scale it, because obviously building a few is not easy, but scaling it is quite challenging. So where do you see from your experience sort of bottlenecks still occurring? What sort of approaches show promise where they get removed?
Yep. So particularly, I end up working on battery packs mostly, and Tesla Mega Packs, so I'll be able to provide more insight on that particular topic. I could think of 2 or 3 bottlenecks, one being how we basically bring the battery cells to the stations. So in high vertically integrated factories like Tesla's Austin factory or Nevada factory, where tens of thousand vehicles we make that like every week or so. So how do we get millions of cells every week in the particular station without getting much damaged? Second thing is not having mixed variant of cells on the same conveyor, because that basically increases more work down the line in various stations. So that was one of the bottleneck, and we had to figure out a way to divert the numerous amount of like battery cells coming into the battery pack lines from the battery manufacturing part of the factory. Second is how we end up aging the battery cells once electrolytes were filled into them. There is deeply involved or highly involved process of like rising the temperature and then cooling them down, just to stress test how they will perform once they are assembled in a pack and have been kept underneath the car to dry them. And to be able to maintain the strong performance of the battery cell, um, battery manufacturers need to use thermal interface materials that basically keeps the power electronics, which is controlling the battery packs, in a standard temperature ranges. And second is the potting, because there are lots of cells sitting right next to each other, and we basically want to prevent electrolyte coming out and shorting positive and negative terminal of the battery. Hence, like it could uh, uh, do basically measure damage if that happens on the road. So allowing this process to happen efficiently on the line, as well as um, producing more number of packs, is challenging. So that was the second bottleneck. In order to like resolve this, engineers need to think through the layout of the factory, as well as how they'll be accelerating the curing time for the potting that we put in, as well as the different kind of glues that we need to put in on power electronics. So those are some of the bottlenecks, but that could be easily challenged or solved by how we lay out the factories and think through those through various platforms that we have available. Those are some bottlenecks that I could think of, and there are definitely tools out there that could help us.
I mean, that demonstrates the complexity of battery pack assembly. I've had a bit of a fascination about just how challenging that is. You touched upon some of those key points there, and I'm assuming when you're talking about potting the battery cells and then curing the materials that are being used, so the layout of the factory keeps the flow going to allow those processes to occur without actually pausing the lines or slowing the lines down too much. So that's quite a big thing, isn't it? To when you think about a process, to actually how the line flows, let
Yep.
alone it. So that's quite a big deal. And do you think that's still still a challenge now. And also, I mean, the minute I would say let's look in the Western markets rather than China, where the volumes are a lot lower at the moment. So the battery pack is manageable at possibly the rates they're doing. But in terms of scaling them from, like, if you take a battery pack and say you've got to match like ICE units, which would be in the millions, do you see like those challenges still being there, or do you think that that the potting materials are getting better, so they do faster cures and things like that? Is that sort of thing coming through?
Yes, definitely has gone down. I believe when we were scaling the Tesla's Nevada factory, I think down there we were building the first of its kind factory that Tesla had ever made. At that point, we had a pilot line, so we were testing different kind of materials, and then scaling it that to like factory scale. So it took us some time, but last 5% of like getting the OEE for the curing time was the most challenging as compared to, let's say, getting from 70 to 90%. It's definitely getting better. I feel like when we lay out all the structure for the multiple stations where the modules need to travel after they have been ported or cured, um, through iterations and frequent revamping of stations where the module would get processed and would get stacked, that is definitely going better. So yeah, there's a curve when it comes to like flattening all of those issues and solving them. I end up seeing far less problems on Tesla's Austin factory. That's where now Tesla makes most amount of packs. So yep, it's solvable.